Cool. All right. Well, yeah. So I have a couple questions for this group actually, if that's all right. I'd hope to make this slightly more interactive, and I know that I hope that we're all among friends here. So if there's any shyness or those kinds of things, I hope to dispel that. I'm curious for each of you who are here, what, if any, interaction have you had in your daily life, either inside medicine or otherwise, with quote unquote artificial intelligence, whatever that term may mean, and we'll talk about what that means in a minute. But I'm curious when I say that, how does AI affect your life today? What would each of you say to that?
So we're free to unmute our microphones and speak to the question, just for get started. Anyone who's interested to break the ice.
Hello, good day. Okay, I'm happy to be on this platform. Thanks to the host and thanks to the speaker. For me, I think my own interaction with artificial intelligence is as far as writing. I think with new editor apps like not new per se, Grammarly and so like all those artificial intelligence apps that can help you edit, especially when you're doing manuscript writing and with like reference management. I mean, with you, for example, partaking in reviews now with the Rayon app is so much easier. Work where you have to go through lots of papers and read manually. With new artificial intelligence tools, you can cut down that time to significant chunks. So I think that's my own exposure per se with AI.
Thanks, that's helpful. Who's next?
I think I'll go next. Well, for me, it's mostly with large language models, ChatGPT mostly. And so it's practically find out I'm trying to get across a new idea or something. It's a quick resource to get direct responses as opposed to Google, which you actively have to filter out information. So it's made it very much easy to access information on any subject matter.
All right. Who's next? All right, testimony. Can anyone you want to give it a shot? Yep. Well, there goes one. All right. Who's next up? If you're having trouble speaking or you're not in a setting where you can unmute for a variety of reasons, I've put up this whiteboard so that people can type directly into the whiteboard if they're interested. And the prompt question I'll put up at the top here, which is, how do you interact with AI? So yeah, so I'll leave that up for a second. I believe everybody should be able to type on that. So I like to start with this because I think that the two technologies that you all have mentioned are extremely prevalent. Oh, sorry. So the question was, how do you interact with AI today? And feel free to either unmute or answer it, or if you'd like to prefer to type directly into the whiteboard.
Hello, everyone. Hello. Can you hear me?
Loud and clear.
Okay. Good evening, everyone from Nigeria. Well, for me, it has to be ChatGPT. For me, I use Bing. It's a kind of it's sort of Chrome, but has ChatGPT there, whereby you can type something directly and then it just gives you the answer without having to. If I go to Chrome, for example, and then I have to search for
let's say, particular condition. It might just be roaming around, okay, but the ChatGPT will just give me the answer directly as I'm. Of course, it's not always 100%, but when I ask one or two, three questions, I might just get something I need directly without having to just roam around other sources. And that's just it for me. And a couple of other things, but this particular one is one of the ways I kind of interact with AI. Thank you very much, sir.
Cool. Thank you. All right. Anyone else want to volunteer anything? It's very helpful for me as the speaker. And I think it's an interesting conversation. So does anyone else use any AI or have any interaction with AI today?
Good evening. This is Tai from Nigeria. Please, can I be heard?
Perfect. Loud and clear.
Yeah. So I think my own one of the ways I interact with AI is through the use of Google text to speech. Also like giving instruction like something like I mean things like, hey Google, kindly set an alarm for me for this particular time. Can you help me play a song? Like things that you would usually want to do yourself, and now you can easily just give the instruction to the Google AI, and it helps you to carry out such tasks on your phone. I think it's another way I get to interact with artificial intelligence. Thank you.
Awesome. Awesome. And somebody's typing in Copilot. Yes, I love it. So I think these are important technologies to talk about because when our expectations, for medical AI are going to come from the consumer technology that we see and the consumer technology we have experience with. And this is going to come both in terms of performance and in terms of user interface and user experience. So we've talked, folks have mentioned important concerns of I use this type of technology because it's easier, because it gives me an answer quicker, because it actually does what I want it to do instead of I have to figure out what the right magic words are to type into Google. Rather, if I talk to, chat with ChatGPT, when I chat to it, we're having a human interaction, right? And potentially in multiple languages. The concept of text to speech where you don't even have to type. Those are all critical. And I think that those are very useful. And of course, when we talk about Copilot for GitHub and
Hello?
coding and other things, yes, please go ahead.
Hello, good evening. Can everyone hear me?
Loud and clear.
Okay, I've been trying to speak for a while now. Okay, so how I've interacted with AI. Well, recently I came across this app, Listening IO. It's an app that allows you or that helps sort of translate PDF files to audio. So things like research papers, review articles, and all of that. So I don't have to. In fact, I enjoyed it. Okay, I used the free subscription for a while though, but I enjoyed it because a lot of, should I say, boring text gets translated to audio, and so it's really cool. And also I use the Google Translator too once in a while. So that's basically my involvement with AI. Okay, yeah, and there's this um assistant, this bank apps that have these AI assistants that you can just chat with, direct customer service without having to call and stay on the queue before you can make your complaint. So thanks.
Awesome. Yeah, and I love that last thing that you just mentioned because you could very easily see how that paradigm is going to be translated into medicine. You can very clearly see the problems that we have with quote unquote customer service in medicine and how difficult it is to access expertise. And you can easily imagine a medical chatbot that can help guide people through some simple questions and the challenges that that's going to bring. What happens when someone asks this, or how do we know we won't, fall victim to adversarial behavior? Or how do we know that it won't reveal protected health information? Yeah, Quillbot is great, all of these types of services. So we'll get into it a little bit here now. But I really appreciate the engagement and interaction, and I also welcome you to either raise hands or interact in other ways during the session, as it's your nighttime, and if you're taking the time to be here, I want to be open to having as much bandwidth of interaction as we can. I'm going to share a screen, so we may lose this whiteboard, but I think we have a good idea and understanding. Let's see where we are. Let's try this. All right. Can everyone see my screen here?
Yes, sir.
All right. So we'll just go ahead and get into it. And everyone sees the correct screen, yeah? Cool. So this is, this is something I spend a lot of my time on, is specifically thinking about artificial intelligence systems in surgery. And I want to focus a lot of the application to surgery. Now, it's not the first place that we're going to actually find AI interacting with humans in medicine, but it is for me one of the most important use cases. So that's where my work starts. I have some disclosures, including funding from the National Institutes of Health, and unvalued equity in an AI startup that's not related to this talk. I have additional consulting conflicts that are also not related to this talk. And most importantly, and highly related to this talk, I founded a nonprofit venture called SDSC, which we'll talk about a little bit at the end. It doesn't make money for anybody, so it's not a financial conflict, but it's a tremendous conflict in terms of I spend a lot of my time thinking about this kind of stuff and actually putting it into practice every day. And it's a conflict because I hope it's something I can actually convince you perhaps to be interested in, and maybe even it's a way we can all participate. We have some work that we're doing with surgeons in Ethiopia and Brazil and India and Egypt and et cetera, and it would be an absolute pleasure to build bridges to Nigeria as well. My real disclosures are that I'm not an AI enthusiast. I don't think that I'm an AI expert, nor do I think that AI experts really exist. Pretty much anyone who says they're an expert, you probably shouldn't trust them. I think that we still underestimate the effects of AI, although it's not going to replace doctors and it's not going to lead to human extinction. It's going to have two different sets of impacts that we'll talk about through this talk. One set that's going to be extremely jarring and feel extremely scary to people, and the other is going to be slow and creeping. And I think that's the one that we really need to keep our eyes on, although all the attention is going to go to the former. So as far as a mission of what we do, what I do, it's essentially this answering this question is the why. Why do we need to make surgery and surgical knowledge better, faster, safer, more accurate, better distributed? And for me, the answer to that question is very simple. We know that actually most people on Earth don't have access to safe surgery, either because they're too far from a major center, or because even the center that they have near them may not be able to provide standards that those of us in major cities would accept in any country. The other problem that we have, in addition to access, is quality. We know that more than 4 million people a year die within 30 days of surgery. That means we have more deaths in the perioperative period than lung cancer and diabetes put together. That's a problem, and I think we have to tackle it. So why does this happen? Well, there's this other interesting thing that nobody likes to talk about in surgery, which is that surgeons achieve different outcomes for a very similar case, for a very similar patient that's just as difficult. And this is a reliable effect. We've seen this across every single field of surgery we've measured, from coronary artery bypass grafting to abdominal cancer surgery to my love, which is pituitary surgery. One way that we've couched this description is as a volume outcome effect, but I actually don't think that's A, what's going on, and B, that's a helpful way to describe it. But those are the tools that we've had from the last 30 years of how to describe risk-adjusted differences in surgeon outcomes. So what we've seen is that surgeons who operate more cases of a given type generally have better outcomes for equivalent risk-adjusted patients. I want to propose to you that this is not a sign of a healthy system globally. And these three things put together are actually profoundly harmful and maybe something that's worth spending our lives tackling at a larger level than our individual surgical expertise, which is clearly one answer to the problem. The reason I don't like this volume outcome framing and why I want to propose something different here, it implies a solution to the problem is increasing surgical volume. But how do I do that as a surgeon? Do I put more brain tumors in kids? Do I elbow out my partners for cases? It also creates really, really bad incentives problems, right? If you're not at a center of excellence, then should you just stop doing surgery and give up? Is that really what my economic incentives are, my sort of altruistic, social, personal incentives? It just kind of doesn't line up. And again, at an individual and surgical level, it may not be even achievable. But most importantly, and this is where I want to spend most of the majority of our time when we talk about AI, it discourages improvement. Because if the only way I can get better as a surgeon is by operating more cases, then there's nothing else I can do. It doesn't matter. Nothing else matters, right? And I think that that's a really, really profoundly bad and dangerous and harmful model of thinking about performance and excellence. And it's simply not the way that we think about performance in any other field. So how do we break this cycle? And where does AI come into this? So here's the problem in surgery. We've studied preoperative factors tremendously, right? We know all of these things about pituitary surgery, about what patients are going to have complications, what kind of complications they're going to have, what the risk factors are for complications. And we've studied all these surgical approaches going back more than 100 years in terms of pituitary surgery, actually coming up to 120 or 30, depending on when you think about the first transfacial approaches to pituitary gland. Right, and this is a picture on the left is from Harvey Cushing's notebook, and on the right is other historical surgical approaches. Right, so we've literally, been thinking about this as a field for 100 years. So I think the approach question, I think we've maxed that out. We're getting minimal returns, and we studied all these postoperative factors that really do matter. Right, things like fluid restriction after endonasal surgery, they really make a big difference on postoperative hyponatremia. But there's something missing, and what's missing is actually the part that everyone on this call, everyone in this field cares the most about. And so maybe that's what we should study. Well, what are we talking about? We're talking about surgery itself, what we do in the operating room and how we do it. And how can we study that? And why haven't we? So, I got introduced to this problem about 10 years ago. When we started working on a simulator model to treat a major vascular complication during endoscopic skull-base surgery, which is carotid artery injury. We created a training course using perfused cadavers. We had all these lifelike things. We trained hundreds of surgeons across the United States for many years. And we had fun with it. And this is sort of the lesson of surgical performance improvement, is that when you're doing it right, it's fun. These are pictures of surgeons that are managing carotid injuries, but in the simulator. And you can see they're smiling, they're laughing, they're getting excited, they're talking about their techniques, they're teaching, right? And that is, before I go to this slide in a second, I'll just tell you, that is not the mood of the operating room when you have a real carotid injury. So simulation is important and has value. And so what do these simulations look like? Why do we think that these might be worthwhile visual models of surgery? Well, let's take a look. On the right, you have a simulated carotid injury, and on the left, you have a real carotid injury. So you'll see both of these videos play through, and you'll see the techniques that we use to manage these. So unfortunately, right, that's your simulated injury. And then that's your real injury. There's a trainee who got lost their orientation in the operating room, and there's a lot of human factors into why that particular event happened that I'm happy to talk about. But ultimately, we were able to fix the injury using the exact same techniques that you're seeing in the simulated video on the right. We had this bipolar that we can use in the endonasal operating room that we didn't have in the simulator. We turned a large hole into a small hole, crush up some muscle graft, plug it up. Ultimately we were able to save this carotid artery, and this isn't a tumor surgery. We were able to save this carotid artery, and you can see there, didn't need to do a bypass, didn't need to sacrifice the vessel. There's no pseudoaneurysm. The patient did well by applying these same techniques we learned in the simulator. So they're lifelike. And one of the things that we found that was interesting in this simulator data was it turns out that you actually can make surgeons better with a very small amount of time of practice and rehearsal. And there were real differences both within attending group and between attendings and residents and their ability to rapidly and effectively achieve hemostasis from carotid artery hemorrhage. Folks lost less blood after they learned the techniques, and they were more likely to succeed in stopping the hemorrhage itself. So that after about 15 minutes, the residents were almost at attending level performance, which is a pretty big impact for a 15-minute training exercise. So we had great improvements. We were able to do a lot of these nice little experiments about, so this is a particularly controversial one. So you ask surgeons, right, can you stop a carotid artery injury if you get one? And it turns out that before they've actually ever tried to do it in the simulator, their responses don't mean anything. They have no idea. But after they've actually done it, then it means something, right? Then when they say that they can do it, they can actually do it. So this should give us a lot of pause into thinking about how surgeons self-assess. But I don't want to go too far down this digression. We can see that practice makes a big difference. Coaching made a much bigger difference, so that there's knowledge transfer. It's not just getting more repetitions. That's actually the critical part to learning this and almost any surgical skill. So this is the work that we did, and this was sort of my entry into artificial intelligence. Well, how does this happen? Well, around this time, something else happened in my life. So my son was born, and you can see him here. And one of the things that we started getting is we started getting these emails in our inbox, and they had all of these metrics about his sleep and how efficient he was and how long he was sleeping and how many times he was waking up and how long it took him to fall asleep. And what's more, they started giving us suggestions. Hey, it looks like you could be better parents, and here's how. And we were a little confused by this, like what is going on here? Where is all of this coming from? And how could this be useful in surgery? Who's watching my kid at night? So it turns out, now we'll backtrack a little bit and let's talk a little bit about AI. So like most quote unquote news stories, this story is more than 60 years old. The actual beginning of artificial intelligence as a field started actually where I went to college, almost 70 years ago at this point, where we developed this particular type of computer system that could receive inputs, perform a mathematical function on that input data, and then provide outputs. But the fundamental innovation was in thinking about those functions as a series of operations that could have interconnections, modeled very loosely on the organization of neurons in the human brain. And it turns out that once you start modeling systems in that way, you're able to account for a large number of nonlinear interactions that simple statistical methods like regression have more difficulty solving. So, here's some of the beginning of this concept, which is called a perceptron, or a multi-layer perceptron, when there's several of these different types of neural networks, neurons put together. So this is what it looks like. The reason I show this particular diagram is, number one, I think we all have an intuitive understanding of neuroanatomy and how projections work and how neurons interact, and there's a signaling process. And that there's some processing that's happening both at the level of the axon where it interacts, as well as earlier on. So we sort of get this idea as neuroscientists. And it turns out that images can be modeled in the same way. So an image, once it's displayed on your computer screen, as this one is simply a series of ones and zeros. And it's a long and complicated and high dimensional and very, very high bit rate signal, especially in video. But fundamentally, it's just a series of data. And these techniques have the ability to perform functions on that data, even when perhaps the patterns we're looking for are not known a priori. And we'll talk about what that means in a second. But simply we can perform a function on this video, for example, of this little weird rat looking thing, and detect edges, for example, through a simple convolutional operation, right? We'll talk about what that means in a minute. But what had been going on in society is just as important. This is why we always start with what's the consumer technology and what's our understanding of AI. So Society and computer science had organized itself around the processing of visual data in a very important way. They created a common task framework. So they created a competition and a leaderboard with rules and scores. And every year you could submit your algorithm and it sort of did battle against all the other algorithms at classifying this data set. So the data set is a bunch of images that could be, each image could be from one of several different categories. And it turns out that in 2012, we had a huge breakthrough in how we did this. And by 2015, the best algorithm at this particular competition beat the human beings at saying what's in the picture. That was 10 years ago. So let's just say that it is possible that computational systems can classify an image at least as well, if not better, than human beings. What else can they do? Well, if you can classify what's in the image, you can also potentially localize the object or the tag, the item that you're interested in classifying. Perhaps you can detect multiple objects within the same scene, maybe even identify their boundaries, and maybe even identify the boundaries of the entire scene. And these are common, very common computer vision tasks that we perform every day. So we did this simulation. We had all of these videos of hundreds of surgeons. Image classification has advanced. We're getting machine learning-based insights in our inbox every day. Well, why is all of this happening? And what do we need to know as medical practitioners in order to make sense of the world we live in and potentially harness it? So I want to propose that there's 4 trends that have converged here that we should understand for a minute because they explain how we got here and where the future is likely to go. The first is the mobile explosion. The number of smartphone users is rapidly increasing to cover approximately 100% of the planet. Every device has the ability to send and receive data. The vast majority of modern devices have cameras and video cameras built in. So the proliferation of global data has reached a scale that was previously unimaginable. The amount of new data created every single year is rapidly approaching the amount of all prior data in existence. This is a revolutionary state. And the reason why it's important to know about this is that commercial systems are solving this challenge at scale in every single country on Earth. And if we can come up with valuable, useful, beneficial methods where we can apply these commercial innovations, we can potentially do some revolutionary things in surgery. There's another thing that happened. This has to do with chip architecture that I'm not going to delve too deeply in for this audience, but suffice it to say that a fundamental problem was being approached in the design of computer chips, which is the ability to increase the power at a given chip was actually it was reached. We reached a plateau in the early 2000s. So what do you do when you can't increase the power of a given chip? Well, in order to achieve an equivalent number of computations or continue to increase the number of computations that you can perform, the hope was that you can combine many chips together. And this is the multi-core processor revolution. This is what's in every single graphical processing unit today. The fundamental innovation is not the number of transistors on a given chip or the power on a given chip. That's something we think about. It's actually the ability to thread and combine these computational operations across a number of different processing units. That didn't have to happen. We could have not been able to pull this off as a society, then we wouldn't be having this conversation. But now that we are, we can do some really impressive things. So this is an example of computational power, now not measured in watts or units of energy, but in floating point operations per second. And you can see that something incredible happened right around the same time that we're talking about 2010, 2015, where we entered into this deep learning era, where all of the models that we were training required drastically more training computation. The whole reason why this was possible was because of the multi-core processing universe that we find ourselves in today. And as a similar process was happening with data sets, right? We talked about the proliferation of data. Now that you had the processing power, then the data set size that any of these given neural network-based models, we already explained a little bit about, could increase dramatically and dramatically. But there's one other thing we should talk about, and I'm not going to get too much into the math of this. I'll simply say that there's a critical paper called Attention is All You Need that is one of the first papers, although there are many even much, much older than that if you want to really be a stickler, that describes a novel way of creating these neural network architectures that is tremendously important. That's called the transformer. That's the T in GPT. So this is a fundamental innovation, discovery in technology in 2017. So those are the four ingredients, right? You had data, you had computation, you have a new innovation, and the fourth innovation is something we've already talked about, which is this common task framework. When you have the ability to compete and build on each other's work, you can achieve breakthroughs much more quickly and efficiently. One of the critical ingredients in this, we talked about scoring, and having the ability to submit and all of these things. But one of the critical ingredients is reproducibility, the ability that you and I can both take a given, let's say, paper, right, that hopefully contains a set of code and a set of data, and we can run that ourselves. And that pattern, when it happens, allows every person to build on every other person's work across the world. The reason I'm bringing this up in a talk about surgery is this is the model we want to slowly start building towards. I have no illusion that this is going to happen overnight, but we can learn not just from the applications of these technologies, but we can learn something fundamental about how they were developed and used in the first place that might be different to how we approach surgery today. Can we all reproduce the surgeries that other people are doing? Can we understand them? Can we build on them? Those are the critical questions in my mind. So what does it look like if we start applying these concepts to surgical video data? Well, there are about 5 questions we wanted to go through in the first part of our work, right? Is there actually any information in the video of surgeons performing these carotid artery injury management or other surgeries, entire surgeries? Can we capture and process the data? Can we use very simple, rudimentary, and then eventually more complicated machine learning models to learn new things about surgical procedures and potentially do some good for humanity? So let's go back to the operating room. This is what a common operating room looks like, and many of you have seen stuff like this in this audience. So there's a master surgeon, there are cameras and the light handles, there's neuronavigation platforms, there are big screens, there's all of these devices, all of which are ingesting and performing functions on data. The problem is we don't do anything with that data. And my argument in the next couple of slides is that we should. So here's why. This is a paper from New England Journal. It's now a little bit old, but the message is timeless. The Michigan Bariatric Surgery Collaborative took 20 expert surgeons, these are not trainees, performing laparoscopic gastric bypass surgery. They each watched each other's surgeries, and they rated each other on a 1 to 5 scale. Now, all of the surgeons were rated somewhere between 2.5 to 4, 4.5, because these are fully trained attendings. But still, even within that area, there's a significant difference in surgical skill rating and its effect on risk-adjusted complications. So for 2 equivalent patients, adjusted as best as we can, like we said, we're already good at doing pre and post-operative and all of these other risk-adjusted measures. Well, after we adjust for all of those things, it turns out the surgical skill accounts for somewhere between 3 to 10-fold of the risk of relevant complications. And these are complications that matter. Big things, bowel obstruction, infection, death, return to the operating room, readmission, emergency department visits. These are things that matter to hospitals and to patients. And it turns out that if you're looking at surgical video, you can see relevant differences in how surgeons are operating on similar patients that are strong predictors of these phenomena. So there's something in the video that's valuable, and we know experts can see it. Can machines? So we sought to test this. We've now published a second data set of surgical video that we hope will be exploited by other people. So these are all publicly available. You can go download this. We created a framework for annotating. This is all now old. And we've moved on a little bit beyond using some of these platforms and packages. But we show that you actually can perform these kinds of analytics on surgical video. So this is an example from our work that shows heat maps of where surgical tools were highly prevalent, how surgeons were moving instruments over time. And when you take the kinematics and put them into, again, a simple logistic regression, it's a penalized regression model. you can see that there's a very strong relationship between blood loss and the aggregated measure of how surgeons move instruments. This is not surprising. It's something that we all do intuitively when we're watching people operate, but machines can do this too. And again, this is a very early sort of minimal ML approach. So what can we do when we apply a more complicated machine learning model to this? Well, we did something that was a little bit cheeky, which is we got 4 expert surgeons and we only showed them a minute of the video. We didn't show them the whole thing. And we asked them, is this surgeon going to succeed or fail? And then we asked the model, it's now a slightly more complicated model, the same question. And it turns out, the other thing we asked them was, how much blood is a surgeon going to lose? And it turns out that the model was as good as the expert surgeons in predicting who was going to succeed or fail, and was better than surgeons at predicting blood loss, which is no surprise because surgeons chronically underestimate blood loss. As anyone who's been in the operating room knows, we basically always lie. Part of that is we don't ever have, unless you're in the lab, you don't have an objective measure of ground truth. And you can do much more complicated things too. This is work from a larger group of surgeons looking at both a variety of urologic, robotic, surgical procedures, showing that these models can create understandings of surgical video that can identify gestures and movements and actions. And then when you have those understandings, you can very accurately predict important postoperative outcomes, in this case, nerve function after, for example, prostate cancer surgery, skill of suturing at performing anastomoses and various other things. And I'm not going to delve too much into the specifics of these kinds of things, but suffice it to say that this kind of work is possible, it's feasible, and this is what we're doing all day, every day. The fundamental view is that we should transform surgery from an art into a science so that we can build on each other's work and increase the global understanding of surgery. So this is our answers to those questions. We believe that we can do all of these things. So what's next? Well, this might be an end state that we could get to. A dashboard, a report card for surgery, how long you were in a certain phase, how your metrics were of your movement, what happened during the surgery, where are the highlights, how do you do compared to yourself, and if desired, potentially compared to others. Once you have all of this data from the video, all of these things become possible. But how do we do this at scale? And this is where this conversation for me is particularly important. We know that health data has the power to influence human health. And we've shown over the last 10 or 15 minutes many different ways in which surgical video data particularly can be used to improve human health and improve our understanding of surgery and potentially improve the outcomes of our patients. But it's very hard to get to this data. And one of the critical things that we need to establish is global data unions, global cooperatives that all across the world are working together to a common goal around shared procedures to create greater understanding. And this is not going to happen in one country or one hospital or one surgeon. In order to access the power of the machine learning, deep learning revolution that we previously talked about, you need these massive data sets. So where are they going to come from and how do we get them? So I created this nonprofit organization to solve this problem. This is a surgical data science collective. It performs a variety of functions on this data. It's up and running today. We have a fairly large team of software engineers and allied surgeons who are working on this problem, where you can log on to this platform, and we have surgeons in Ethiopia, Brazil, and Egypt. Again, I mentioned in addition to the United States, overseas in the UK. Upload your video, receive machine learning-based feedback on your video, and even use that to generate papers, research objects, et cetera. So we're working with a series of academic institutions to create a new kind of research based on surgical video itself, where people can use the platform and these insights to better understand what's happening in the operating room and to create a quantitative representation of what they do. So you don't just say, oh, here's my surgery, here's the video. You say, here's my surgery, here are the numbers, here are the moves in order. Here's what we did different from what you did. Or what I did this time different from what I did last time. We have, again, like I said, this global platform and partnership. And we've done a couple of other things over the last year that I think are worth highlighting. We're doing a lot of advocacy work with surgical societies to increase their focus and understanding on AI and machine learning. Like I said, we created this focused research organization, nonprofit, and we've created new meetings. There are going to be aspects of all of the major neurosurgery meetings in the United States this year that are centered around this digital revolution. And we have created a new meeting as well as helping lead those efforts that stands alone. We had it in October and we'll have it again this year. And this is sort of the vision, right? We start with this very sort of private individual model and move very quickly to something that enables research, clinical care improvement, and greater understanding of surgery. This is, how you get on the platform. This is, what we're really about. And I would invite anyone who's interested to join. I'm happy to, discuss this in greater detail of all of the nuts and bolts of this at your various sites. So this is, slides from the meeting that we had. We had the presidents of all of the major neurosurgical societies, members of the board of neurosurgery, major computer scientists from Microsoft and Google, and major medical device manufacturers. And we did something else that was cool. We had a vision symposium that included folks from the military, folks from sports, and folks from the self-driving car world all together in the same room. And that was a really exciting effort that we had. And that was done with my friend and colleague, Sam Brown, who's a pediatric neurosurgeon in Seattle Children's and in Washington, D.C., who's really been phenomenal in leading these efforts. We wrote all of this up before we did it in a paper in White Journal that, described every single thing that we were going to do. We fundamentally believe that neurosurgeons have to lead this effort. And the people who are most likely to lead this kind of an effort are the people who are listening to this kind of call, young neurosurgeons, young medical students in training, who are more, have had this, understanding of AI baked into their lives at a greater, a greater intensity than really any of us have. So I think this is really the right audience. So what about ChatGPT? We always have to talk about ChatGPT. So there's some challenges. There's some tricky things about ChatGPT, as you guys all know if you're using it. It's highly non-deterministic, which means that if you ask it the same question on 2 different sessions, you'll get 2 different answers. It also means that exactly how you ask the question highly determines what it's going to say. So if you ask it to write a bad answer, it'll write a bad answer. But conversely, if you ask it to write a really good answer, that's how you get it to write a really good answer. You can't just ask it a question. So there's all these weird ins and outs of this, but it turns out that we are getting close to the point where GPTs, and ChatGPT is one example of these general pre-trained transformers. We're getting to the point where their performance is going to become undeniable at common tasks, things that are seen on the internet at least 4 times, is my joke. So for reference, the graph on the left shows the performance of various large language models against a standard medical question asking data set that's essentially USMLE style questions. And about 60-65% is passing. And we're up in the 90s with GPT-4. Now, there's some ins and outs of exactly how this is created. So I don't entirely agree with the statement that GPT-4 can pass the USMLE. We haven't given it a test in the USMLE room. We don't quite know that. But there's a very good reason to believe that it can answer USMLE style questions, as well as some of the best medical students. And heck, at my age, probably better than me. And what does that mean about what we should expect from these systems? So there's a series of progression in the development of these models, ranging from vision models, like we talked about, that are very specific, to pre-trained models that have narrow but highly effective skill sets, to what we call more foundational models. And these have emergent properties, which is to say properties that we didn't know about when we created these models and didn't explicitly train them for or test them on, but that they demonstrate later on. And this is something that's truly interesting. And this is where a lot of the fear of AI comes in. And the last thing is instruction following assistants, right? These general purpose assistants, right? And this is where a lot of the utility of large language models comes in today, and most of the examples that you've seen. So what does this look like in medicine? And what about medical images? So vision has been generally the second to last frontier, and video vision is truly the last frontier in large language models. So it turns out that you can take an open source model and train it to be a language and vision capable assistant for medical applications, where it can describe radiographic images, pathology slides, histopathology quite effectively in less than a day of computer time. This is an example of what the output looks like, where you give it a slice from a chest CT and ask it some questions based on the information provided that mimics in some ways a radiology report. It says, okay, look, this person might have a cancer, could be TB. Here's what we think is going on here, and you can ask it these questions. So where are we going? I think we can see that we're going to have a frame shift in how we think about surgery. Right now, surgery is largely uncoached. We get no feedback. We have very minimal performance data. We rely on our own best practices, and we're really training. We're learning, we're getting better every single case that we do, and the only way we have to get better is by cases. In the not so distant future, and single digit number of years, we're moving towards paradigms that look and feel more like chess. You have virtual coaches, real-time feedback, performance tracking, libraries of data you can consult, including of your own and others, and we're updating. We're not necessarily reinventing the wheel every single time we perform a surgical procedure, because we have that information at our fingertips. Just like the computer code that we can reproduce, we can now re-render someone else's surgical procedure and say, oh, okay, I see that, and I'm going to build on that by doing this thing in my particular surgery. That's the vision of where we want to go. We know we have the data to do it, and it's simply a question of doing the work. I think that this is an exciting challenge, and I want to leave a couple minutes for questions always at the end of this. All of the images that were not from the operating room and some that are from the operating room in this talk were generated by AI. We use all these things on a daily basis. And this is how you can find me on socials, email, this is something that I'm very excited about, and I think is going to make a big impact on all of our careers. What I'm hoping for as a direct result of this conversation is to understand whether and how some of you may be interested in participating in some of these video sharing projects and anything else that are interesting to you. So I'm going to pause there and stop the screen share, and I'm happy to leave the last about 5 minutes or so for any questions you may have.
Hello, can everyone hear me?
Sounds good.
Okay. All right. Thank you, Dr. Donoho. I hope I pronounced that correctly. Okay. So, thanks to everyone for listening in. So it was a very insightful, lesson, basically. So, if you have questions, please feel free to unmute or type your questions in the chat box.
Right. Question numero uno. Managing these large data sets. Yes. Well, I pretty much only started with large data sets, so I can't say that our approach has changed too much, but I will say that something that's tremendously important for us that we've learned is to trying to think of the right way to say this. Just go for it. Cloud storage services are becoming cheaper than ever. Infrastructure is becoming increasingly available. Physical storage is cheaper than it's ever been before. So there's a question always of, should I do this now or should I wait for the technology to evolve, because technology is evolving so quickly? I think we're at that inflection point where it's time to go for it. So to answer a specific question, we use cloud storage services for all of our videos. There's common cloud vendors. We perform computations using their elastic cloud computing system. We use AWS for a lot of stuff, although some of the stuff we use Google for, whether it's just simple Google Drive and Colabs, You could get a lot of free computational time that way. And storage on Google at small levels is pretty cheap. So I think the most important thing is making sure you know what you want to do and that you're following the relevant rules and regulations. But within those bounds, I think just start experimenting and go for it. And at the scales that we're talking about, we're at the many terabytes, many terabytes of video data, and that's pretty much where we started. So we've had to have the ability to perform, to compute against that size of video from the beginning.
Oh yeah, thanks for your response. Yes, I'm not sure if someone else has a question, but I'm just curious about if you've met with resistance of any sort with regards to data sharing too, because I perceive this is like a global initiative and you probably expand to other countries beyond what the set of countries you currently work with. So I'm just curious if has there been any resistance with, because I think for this to succeed on a large scale, there has to be some international collaborations and open source data sharing. So I'm just curious if that, and if you think that's going to be a problem in the future, or what measures do you have?
Yeah, there's no better solution for resistance than energy, patience, and alignment. So yeah, there's a lot of challenges in working in this area. Absolutely. But alignment is the most important thing to overcome resistance. One of the nice things about what we do is we're not trying to make a buck off of people. So that's very clear from the beginning. We can work with de-identified data. That's also critical. And between those two things, we've had fairly good success. But in every local context, there's a new challenge. Energy is critical. Having people at each institution who want this to succeed and in each country who want this to succeed is clearly the way to go. And I think you have to be working towards the right purpose that, stakeholders can understand and agree with. And, the question about, regulatory is always, it's actually really not, it's very rarely a question that's actually about regulatory, because we send all kinds of data out of the hospital all the time, right? And the reason we do it is so that the hospital can function as a business. So if you can explain why you're helping the hospital meet its business objectives, helping the stakeholders meet their goals, helping patients have better outcomes, and doing so in a way that doesn't seem like you're trying to take advantage of people, I think this can work. I think other patterns can work too, but they are more difficult. I think that's really the key to overcoming resistance, in my opinion.
Yeah, thanks. Thank you very much. Thank you for your efforts and your work. Yeah, thanks.
So I have a somewhat personal question. Your background, your undergrad was in economics.
Yeah.
So absolutely. So just wondering where exactly at what point did you delve into AI as regards the technicalities up to the current point where you are, for organizing a conference on digital neurosurgery, which had quite a huge attending, and what piece of advice you have for folks like us? We don't exactly get to have such qualitative training during our medical training as regards delving into the field.
Well, like I said, I don't consider myself to be the technical expert in anything, and certainly not in this. But I think the practical understanding and the ability to improve your skills in this has never been easier to acquire. There's a plethora of online coursework, YouTube channels, people on Twitter. I think to be honest, the formal coursework in many ways lags behind the reality of what you actually need. And there are so many, open source repositories of code and all of these things that are so much more available than they were 5 years ago. There's not ever been a better time to just start trying it out on, cat videos and, tabular data about, airplane wings and all of, flower petals is the classic one, right? Car mileage per gallon, whatever you want to use, right? But there are all of these toy data sets that are out there. Again, like I said, I've literally published 2 of these now that you guys can use to, train your own models, try it out. They're labeled, annotated, etc. You know, those are available to you, and I think you just have to go for it and commit. At this case, a fairly short amount of time, right, on the order of months, not years. To upping your skills. The other 2 things, right? I think for me personally, I viewed economics as a way to do modeling of complex systems. So we were doing some quantitative work even in economics. It wasn't, sort of in the abstract theory level, and that's what drew me into that. But more, more importantly, the last part is make friends, right? Get a team. All of this stuff that we've done and completely A to Z. I don't think I've done any of this alone. And I don't think any of this is credit that goes, like I said, credit that goes to me. And I think that anything that's worth doing over the longer arc of your career and working in a team is the way to get those accomplishments actually to have real impact. We're so limited as individuals, and together we each can bring in complementary perspectives. And that's if there's a message of how to do this work, do not try to do it alone. Build up your own skills, yes, but understand that there are people out there who would love to understand how to improve human health and would love to apply their incredible technical knowledge to do this kind of stuff, at a very high level. And you can inspire them. You can. Yeah, it's me. You can, right? Already as a medical student, you understand these issues so much better than a layperson does. And you can identify these interesting areas and problems that you see every day in the hospital, right? You see every day in the clinics, you see every day in your coursework, right? And, people are doing, GPT for, USMLE prep, right? GPT for wards, all these things. You have to be careful with those things, but the person who's going to understand and have the judgment of how to build those systems, that's you, right? It's not the computer scientist, and it's not the business person. And I guess the last part of that I would say is this is truly a transnational world, right? There is no reason that any team, time zones are real. I'll say that as somebody who runs a multinational team. Time zones are really hard. It's hard, as you guys know. It's not, 9 o'clock, right? Like, I don't need to tell you that. So it's hard to run a team that's on every single time zone. But you can do this work, and you can find the people at your local technical, setup who are excited about it. You can, help them and be the inside person and the clinical expert for them as you build up your own, technical skills as well.
Cool. Are there any more questions? Does anyone feel free to unmute and ask your questions?
Good evening. How do we connect with you?
Yeah, I'm happy to put my email in the chat. And yeah, always happy to talk. Happy to help. I think like I said, we work with some organizations that are trying to do a lot of global work, and at my university we just had a big meeting around global health. So there's a big emphasis in wanting to see this kind of work flourish and make an impact throughout the world. And I think the other thing that we've learned from several particular procedures in neurosurgery is the expertise is not concentrated in high-income countries. Excellent surgery is not located in high-income countries. Excellent surgery is distributed across the world. There's excellent surgeons and technical masters in every single country on earth, and in some countries more than others, without regard to how affluent the country is or how complex the technology the surgeon has available to them. And one of the reasons is we talked about that volume outcome phenomenon a little bit, which while I don't like it, the reality is also that somebody who lives in a city where they're seeing 100 times more of a certain disease, at this point in time, they're probably the expert in that, probably more than me. So I don't want to teach them, I want to learn from them. And that's the kind of interaction that we want to power, because there's no way to do that right now, right? It doesn't work. So that's the connection we want.
All right, thank you very much, sir. Okay, any more questions? Please feel free to unmute or type in the chat box. Any questions?
Okay, one final question, if I may ask.
Okay.
Okay, this is not in regards to the lecture, but generally on neurosurgery. I'm a third-year medical student. What do you think is something I can do to stand out as a neurosurgeon in the future and make great contributions to the field?
Yeah, just curiosity. I think understanding technically in the operating room, understanding why people do what they do and why they don't do other things. And from how they position or drape the patient to how they perform a skin incision to how they clip an aneurysm, and everything in between. I think that gets you very, very far. And as far as how you can stand out, I think that's sort of context dependent. So it's hard to give a generalist piece of advice, and I kind of don't really believe in advice because it assumes that I know more about your life than you do. But I will say that probably the best way that I've seen that medical students stand out positively is when they're energetic and optimistic and understand the social context that they find themselves in and can make a team better. And that's how I know that person, when they join my team, is going to make my team better. So finding the ways that you can help solve problems for other people before they even know they exist within the context of the role where you are, that's a skill that really stands out.
Okay, thank you, sir.
All right, thanks, guys. Have a good night.
Yes, thank you, sir, for the session. So then,
Thank you very much, sir.
All right, thanks all. We'll see you later.
Thank you very much, sir.
Same here.